Mic check. Mic check. Mic check. Mic check. Mic check. Okay, guys, can you hear me?
Yes, sir.
Yes, sir.
All right. Welcome to the world premiere of Topic 1. Right? This is the world premiere of Topic 1, right? Topic 1 and 2. I'm in the correct theater, right? Side. All right. So, how are we doing? Are we okay? The stress not supposed to start yet, right? Hmm. They say, Evelyn, the stress started?
No, sir. I'm not.
All right, cool. No problem. All right, so we are going to be diving into Topic 1 and 2. All right. Part of this module is going to be supporting you guys in your studio class. So, what are you guys doing now in studio?
Doing a site analysis, sir.
Okay.
So we're doing a research of Pearl.
Oh, okay, cool. LeSean would beg to differ, but the stress start already. All right. Okay. So we're gonna dive into let's count like how we learn how to count. So topic 1 is Ilandra, Daniel, and Jadmar ready?
Hello, sir.
Yeah, man. Good
Oh,
to
you
go?
asked if we're ready? Yeah, I think so.
All right, good to go. No problem. Remember, this is more of like a presentation discussion, so don't worry about it too much, right? We should also be asking the questions. So if you guys remember the procedure, we present and then the other groups ask a question. We're going to do the 2 presentations first. Yeah, we did 2 presentations first and then we ask questions. All right, equal questions to the amount of persons, so you can't ask group 1 questions only. All right, and so forth. All right. So let me stop my share.
Excuse me, sir.
Yeah, man, what's up?
This is Elandra speaking. Just to clarify,
Mhm.
are we asking the class the questions or is the class asking the group the questions?
A member from each group is going to ask the presenting group a question. So it's the class asking the group, but it's not the class as in just random people from the class. So for example, when you're done present, I'm going to say, group 2, what's your question? And who you asking it to? Group 3, what's your question? Group 4, what's your question? So everybody going to get a chance to ask one question. So at the end of the day, each group should answer 5 questions. So go. Yes, I hope I got that calculation. All right. So it's the other groups that didn't present today that's asking the question. One question per group. All right.
Okay, sir. Thank you.
All right. Topic 1, you're on the floor.
Sir, you can see my screen, right?
Yeah, man, I can see it.
Okay.
Okay, so good afternoon, everyone. This is Group 1, and the group members are Daniel Davis, Danry Marshall, and Elandra Lewis. And the topic that we got are, what are the types of 3D modeling techniques and their applications in architecture? Okay, so for this presentation, we'll be talking about what 3D modeling is, the difference between 2D and 3D modeling, the advantages and disadvantages of 3D modeling, the types of modeling techniques and their benefits, what is being modeled, and the 3D software or tools being used.
Not hearing the audio.
Now here,
All right. Remember, you have to click share audio when you. Mhm. You're using using Zoom, so that under the when you click share screen on the right side,
Okay.
you check the share audio.
Well, I don't see it, sir.
You don't see it on yours. When you click share and then the different screens come up.
Oh, so
So
is
I
it a
could,
case where
so
I'd have to stop sharing and start sharing again?
well, yeah, just stop share it and start share it again, just to make it
Alright.
clear. Right, right, and then start again, and then on the right hand side where you see
Oh, share sound. Okay.
yeah, and then choose the optimize. Oh, yeah, it's fine. Let's go. It's fine.
Hello,
Can you hear that?
Yeah, man, good to go.
Alright.
my name is James Knoll, and I'm a highway engineer at Dewberry's Mount Laurel office. 3D modeling is a technique in computer graphics for producing three-dimensional representations of objects or surfaces. In recent years, 3D modeling has become widely used in a large variety of industries and mediums. An artist may use a special software to develop a three-dimensional representation of scenery or characters for use in illustrations, video games, or movies, while an engineer or architect may use a similar software to create 3D models of their projects and design. Prior to the advent of computers, engineering designs had been drafted by hand. But as technology evolved, computer software became a common engineering tool. Currently, designs and plans are drafted using computer-aided design software, and the visuals created are generally in 2 dimensions. Since the engineering design process is very iterative, whenever a change to the design is made, the visual generally needs to be changed as well. By using 3D modeling, it is possible to more easily see how the changes in one area of the design may affect the overall design. For example, a 3D model of a pipe network may reveal that several pipes in the network are colliding with each other, or that the pipes might be colliding with other design elements. For a highway engineer, a model of a roadway may show that raising the profile in one area may cause drainage issues down the road. While it may be possible to spot many of these issues with a two-dimensional representation, depending on the complexity of the design, it will likely be difficult and time-consuming. But with 3D models, it is easier to locate these issues and determine how to correct them. Overall, 3D modeling allows engineers to develop a better understanding of what their designs will look like once constructed, thus making it an invaluable tool for developing more accurate and constructible designs. Thank you.
Okay, so what is the difference between 2D and 3D modeling? 2D drafting in architecture is a process of producing flat representations of structures, such as elevations or floor plans. However, by incorporating perspective and depth, 3D modeling makes projects come to life. 3D models provide a thorough view from multiple perspectives, in contrast to 2D blueprints, which might be restrictive when it comes to project visualization.
So some advantages of 3D modeling include enhanced visualization and spatial understanding, improved communication and collaboration, and increased efficiency in design scheduling. On the other hand, the disadvantages of 3D modeling includes the high initial costs for the software and the powerful hardware. There's a steep learning curve required, so there's significant time and training that put into it. It's also time intensive. It's a time intensive process for creating detailed models. The types of 3D modeling techniques include the building information modeling, known as BIM, wireframe modeling, primitive modeling, parametric modeling, point cloud modeling, and spline modeling.
Okay, building information modeling, BIM is a cutting-edge technology that is helpful for architectural visualization in both management and construction. It also makes feasible to build intelligent models and calculate the quantity of materials required, the building time, and the total cost of the project. This technology aids in iterative design to create more environmentally friendly structures and make efficient use of all available spaces. It occurs in a cloud-based setting and is quite cooperative, allowing construction crews to stay up to date on the latest developments. Some 3D softwares that requires BIM are Autodesk Revit, SketchUp, and ArchiCAD.
So the pros, I would say, for the BIM modeling technique is that there is improved visualization. This provides realistic 3D models that help the stakeholders understand the project better in comparison to the 2D drawings. There's also enhanced collaboration. The centralized model allows architects, engineers, and contractors to communicate with the clients on the same platform, reducing miscommunication. Clash detection, it identifies design conflicts, example, the pipes running through beams early, saving costly rework during the construction. The cons include there's a high initial cost for the software license, the training, and the hardware upgrades. They all can be expensive. There's a steep learning curve. It requires significant training and experience to use effectively, and the standardization problems. So different organizations or countries may use different BIM standards, creating somewhat of a interoperability issue. Yeah. Wireframe modeling. Wireframe modeling is also referred to as Edge modeling, it entails the creation of skeletal deception of an abstract edge of the real-world item. It is a basic and one of the quickest ways of creating 3D visuals. With wireframe modeling, a designer uses lines, circles, and other shapes to build geometric representation of an object. These lines provide a clear and precise definition of objects' points. The type of modeling might be compared to preliminary design plan or rough drawing. Wireframe softwares include Miro board used in class, the Adobe XD, and Figma. Some pros of the wireframe modeling includes simplicity and speed. The wireframes are lightweight and quick to create, making them ideal for initial concept development. Another pro is that it's low computational load. Because only edges and vertices are shown, the wireframe requires less processing power than surface or solid models. It's a clear visualization. They provide clear understanding and underlying geometry and proportions of the design. The cons of wireframe modeling. So sometimes there's a lack of realism. The wireframes do not represent textures, materials, or lighting, making them less useful for presentation or realistic visualization. Ambiguity in complex models. So as you can see on the image, the overlapping lines and edges can make complex wireframes confusing and hard to interpret. No mass or volume information. They don't provide data on weight, density, or material behavior, which limits engineering analysis. Primitive modeling. Primitive modeling in architecture is a 3D modeling technique that uses fundamental geometric shapes like cubes, spheres, and cylinders as the basic building blocks to construct more complex architectural models. These primitive shapes are often combined, scaled, and manipulated by Boolean operators such as union, subtract, and intersect to develop a desired layout and forms for architectural design. Some primitive softwares include Blender, FreeCAD, Fusion 360. The pros of the primitive modeling include simplicity. It's easy to learn and understand, making it beginner friendly. It's fast prototyping, good for quickly blocking out shapes and visualizing ideas. It has a low computational cost. Since the primitives are mathematically simple, they require fewer resources to render or manipulate. Some cons include the limited detail. It cannot capture complex organic or irregular shapes effectively. There can be some unrealistic results, so the models can look a bit blocky or unnatural if not further refined. It's also time consuming for the refinement. To reach realism, primitive models often need to be heavily modified or combined with other techniques. Parametric modeling. Parametric 3D modeling enables unrivaled precision when refined and production design. Yet, it is a lengthy procedure. By simply adding a set of parameters, an editing model may be created. Since it demands incredibly precise measurements, it cannot be incorporated in early stages of a project, therefore frequently works well in conjunction with direct modeling. Adding new parameters allow for the creation of modification of objects. Therefore, any modification has potential to impact the overall design. This modeling technique highlights that creative solutions can be created. Parametric softwares include Rhino with the Grasshopper, Autodesk Fusion 360, and Satya. Yeah. Some pros of the parametric modeling include design flexibility and control. Parameters, such as the dimensions, constraints, relationships, can be adjusted at any time, and the model updates automatically, making it easy to explore design variations without starting over. Efficiency in iteration. It saves time when changes are required, especially in projects with multiple parts for assemblies that depend on each other. Accuracy and consistency. Relationships, example, if you say like this hole stays centered on the face, it ensures that the design intent is preserved even when the dimensions change. Some cons include the steep learning curve. So the parametric modeling requires strong knowledge of parameters, constraints, and software tools, which can be intimidating for beginners, you know. So and there's also high computational demand. Complex parametric models can become heavy, slowing down processing and requiring powerful hardware. Over constraint or model breakage. Poorly planned parameter relationships can cause errors or make the model unstable when the dimensions change.
All right, guys, keep it going. You have
Okay,
like 5 minutes in your time.
point cloud modeling. So point cloud modeling, occasionally referred to as scan to BIM, is a 3D computer graphics and modeling technique in which a sizable collection of points in three-dimensional spaces is utilized to depict the environment or structure. Usually, a variety of scanning technologies like photography or LDAR, light detection and ranging, are used to record these points. In point cloud modeling, every point in the data set has information about where it is in 3 dimensions, along with maybe other characteristics like color or intensity. A thorough and precise 3D representation of the scanned object or environment can be constructed by processing and evaluating these points. So softwares that use point cloud are Ondet, Cloud Compare, and MeshLab. Okay, so the pros of point cloud modeling are high accuracy and detail. It captures exact dimensions and shapes of real-world objects, even with complex geometries. Laser scanning or photogrammetry ensures millimeter-level precision. Speed in data collection. Scanning a site or object is much faster than manual measurement or traditional survey methods. Comprehensive documentation. It provides a complete digital record of existing conditions useful for restoration, renovation, and maintenance. Oh, cons of point cloud modeling are a large data size and processing needs. Point cloud files are massive, requiring high computing power, storage, and specialized software. Processing into unusable 3D or BIM models can be time intensive. High cost on equipment and software. Laser scanners, drones, and photogrammetry tools are expensive. Professional software license add to project cost. Complexity of data handling. Required skills, personnel to clean, register, and interpret point clouds. Raw scans often include noise and need refinement. Spline modeling. This modeling technique allows you to design 3D structures having complex forms using splines, which are 2D elements like lines and circles. Given that it makes it possible to utilize tools, Bezier curves, spline modeling is often used to quickly construct 3D models with multiple curves. So some spline softwares are non-uniform rational B-spline software like Autodesk, Maya, Rhino, and AutoCAD. So some pros for are precision and smoothness. Splines allow for the creation of highly precise, smooth, and mathematically perfect curves and surfaces, making them ideal for industrial designs, logos, and organic shapes. Fine control. So this modeling provides fine control over the shape and curvature of the 3D model through manipulation of controlling points, allowing for detailed surface adjustments. Efficiency. This modeling results in models that take up less data space compared to models with a vast number of polygons.
Okay, and some cons or complexity for detailing. It can be challenging to edit and detail individual parts of spline-based models as its structure is more continuous. Limitations with engines. Game engines and other applications are often better adapted to polygonal models, which can pose compatibility challenges for spline-based designs. High base mesh weight. While spline offers fine control, they can result in higher base weight for the mesh, impacting performance in some contexts.
So 3D modeling techniques in architecture. In architecture, 3D modeling techniques are methods used to digitally represent buildings, landscapes, and structural elements in 3 dimensions. These techniques help architects and designers visualize, analyze, and communicate their ideas before actual construction. The choice of technique depends on the project's requirements, the software being used, and the level of detail needed.
Okay, so essentially, just to wrap this up, this explains the different types of modeling techniques. So you have organic and hard surface, and this kind of shows the benefit, like why different subjects require different methods. You can skim through. Okay, next. So it also is dependent on the 3D software or tool being used. Each software has its strengths that shapes techniques. This is an example of ZBrush. So it's a digital sculpting software, and it differs from traditional polygonal model tools because it focuses more on sculpting in clay using brush and dynamic control over surface details. Similarly with Rhino, it has conceptual design, refinement, parametric design, and exports for production. These are different things that you consider depending. And here is also Maya, 3ds Max, and Blender. And the list on the side just shows like the similarities that it has and why you would choose it based on your specific technique. So they're powerful in 3D modeling and animation. They support polygonal modeling. They provide animation tools for rigging, character movement, and motion graphics. And they include rendering engines for producing realistic style visuals. Mm-hmm. And then there are features within the tool. Even with same programs, different features enable different modeling techniques. So you have, okay, so you have extrusion and subdivision tools, brush systems, modifiers, and procedural nodes. And these features shape the workflow, meaning two artists in the same program can use different techniques depending on which tools they employ. And finally, the workflow determines how techniques are combined. So you have manual workflow, which gives precise hands-on controls, procedural workflows that use algorithms or rule-based systems to create modules, ideas, general sites, etc. And you have hybrid workflows that mixes both, for example, sculpting a base character, then using procedural tools to generate clothing or environments. The flexibility means that no two model, oh, thank you.
All right, topic 1. Thank you. I'm going to save my comments. So what I'll do, after you present, I will comment, and then you ask the question. And then the other group members can ask the question. Because there are some, okay, good, you have references. There are some things that I might have to update or correct in the presentation before you ask the questions, right? All right. So that's topic one. Which was the what are the types of 3D modeling techniques and their applications in architecture? Topic two, advantages and disadvantages of real-time versus offline rendering.
Sir, it's two now.
Yeah, man, two now. We're
Alright.
presenting first, and then we're asking. All right? 15 to 20 minutes. All right?
Okay. So, good afternoon, everyone. This is group 2, and we are presenting on the 3D rendering presentation.
All right. Let's minimize that guy there on the right. Just look on the lower right-hand corner. I think that one. Go down some more. Yeah. Is that one? Yeah. All right. Cool. Yeah, man. Good to go. And you share your audio too, in case you need audio. Remember that. All right, cool. Go ahead. When you're sharing in Zoom.
Wait, sir, you weren't hearing us a while ago.
No, I was just reminding you. I was just reminding so that you don't have to stop and right.
Yeah. Sir, you hearing us? You hearing us?
Yeah, man, I'm hearing you.
Alright.
But
we had some technical difficulties. Sorry about that, sir. In minimize that.
Okay. So, good afternoon, everyone. We are presenting on 3D rendering. So, come along. Okay, so the scope of our presentation, just the basics, the 3D rendering, architectural firms, what is real-time rendering, what is offline rendering, and the advantages and disadvantages and important specs to run real-time versus offline softwares. Okay, the big question, what is 3D rendering? So 3D rendering is the process of using specialized computer software and hardware to convert 3D model data into a 2D image or animation. So basically, just think of it like taking a digital model and giving it a photo, a realistic look. It's almost like taking a picture of something that doesn't exist yet. And I think all of us are quite frank with all of that. So for the advantages, so advantage 1, it allows architects to make design decision quickly by giving a lifelike view of the design. Advantage 2, it's a great tool for architects to communicate design proposal to clients and partners. Advantage 3, it allows the architects to detect design flaws in the early stages before construction. Advantage 4, it enables better collaborations between different fields, landscape, designs, and engineer. So one of the coolest parts about this part is that you spot mistakes before construction. It's basically a cheaper way to fix something in rendering than when the building is halfway done. And since architects often work with engineers, I should say, interior designers and landscapers, renders help everyone to get on the same page visually. So as it relates to architectural firms now, so most architectural firms use both real-time and offline rendering softwares based on the different scenarios. Firms use real-time rendering for quick changes for client previews and offline rendering for the final output or marketing. So just by that alone, you kind of have an idea of where the softwares, both real-time and offline, works or how what we would expect then. Okay, so for 3D rendering in architectural firm, one, again, it allows the architects to make design decisions quicker. Example, material selections, lighting simulations, etc., by giving a lifelike view of the design. Two, it's a great tool for architects to communicate design proposal to clients and partners. It allows architects to detect design flaws in the early stages before construction, and it enables better collaborations between the different fields. So for this, we could say that it's not just about making pretty images, it actually impacts design decisions, like which materials to choose or how natural lighting enters a space. I feel like clients are more likely to approve projects when they can actually see what they're investing in and it feels more real to them. So this is why 3D rendering is actually important and comes into place. And it's basically the collaboration part is huge, and engineers can spot structural issues, landscape designers can see how the building interacts with the environment. So this image basically shows what we're going to get into, real-time rendering versus offline rendering. And just based on the image, you can see the difference on how lighting, if it's a bit more realistic, or, you know, just by getting a general understanding.
Okay, so I will be presenting on what is real-time rendering. Real-time rendering focuses on rendering images or animations in near instantaneous time, allowing for interactive manipulation of the scene. This approach is commonly employed in video games and interactive applications. So what this means is basically that as you are moving through the rendering, like it is rendering in real time, like different environments change in real time, lighting changes in real time as you move through the scene. This is an example of a real-time render or real-time renders. Okay, so real-time rendering scenarios. So we would use real-time rendering for quick turnaround for client preview or studio desk crits, for walkthroughs and virtual reality, and for quicker render times at the cost of realism. Advantages of real-time rendering. Real-time rendering offers high realism, produces the highest quality results, accurate lighting, shadows, reflections, and material properties, handles complex scenes better, large geometry and heavy materials, as well as complex simulations, example, water. Examples, water acoustics, right? Mostly using films. Oh, that's actually offline rendering. All right. Okay, so mostly using films for final visualizations. Software is flexible and allows for CUDA processing, both GPU and CPU, as well as CPU rendering. Performs better in interior close-up renders that require high quality details. Okay, so that was supposed to be for offline rendering. Yeah. Okay, so competitors in real-time softwares include Chaos Enscape, D5 Render, Unreal Engine, Lumion, Chaos Montage, Autodesk Arnold, Twinmotion, and Unity. Here are some examples of the different renders in different rendering softwares: Enscape, Twinmotion, Lumion, Unreal Engine, etc.
What is offline rendering? Offline rendering refers to the traditional method of generating images or animations by computing every pixel in a scene before displaying the final result. This method involves pre-rendering frames or images using powerful computers and can take minutes or even hours per frame to calculate complex lighting, shadows, reflections, and textures. So offline rendering is basically the process of creating high quality, realistic images or animations from 3D models by calculating lighting, shadows, and materials without needing to display results instantly in real time. So this is an example of offline rendering. So scenarios in which offline rendering is used. So ultra realistic renders for marketing or ads. 2, high budget projects where quality is more important than speed. 3, high detail rendering. So it's close-up shots that require high material detail and advanced lighting. So competitors of offline offline softwares include 3ds Max, Chaos Corona, Maxwell, Blender, Arnold, and V-Ray. So V-Ray is an example of a render done in V-Ray. So it's an industry standard renderer in architecture, film, product design, and advertising. Offers both CPU and GPU rendering. It's known for speed, flexibility, and large material library. It balances realism and performance. Widely used by professionals. So this is Chaos Corona, and this is an image with rendering done in software. It's a high quality photorealistic rendering engine known for simplicity and ease of use, especially in architectural visualization. It offers interactive rendering and realistic lighting, material handling. It's a fast learning curve compared to V-Ray or Arnold. This is Blender. It's free, open source 3D creation suite. It includes built-in cycles and Eve render engines. Maxwell Render focuses on unbiased rendering, simulates light with extreme physical accuracy. It produces highly realistic results but can be slow compared to others. It's often used in product design, architecture, photography. This is Arnold. It's an advanced ray tracing renderer used heavily in film and VFX. Physically based with high quality global illumination and shaders, integrated with Maya, 3ds Max, Houdini, and other DCC tools. Production proven in Hollywood movies, Marvel, Pixar, etc.
Okay, so as you know, to do or to pull off renderings, you need a pretty powerful laptop or PC. So the minimum requirement in terms of the RAM or the random access memory is 32 gig. However, some can use 16 gigabytes, but for the best performance is 32 gig up. For more complex jobs or work is 64 gigabytes. Or for handling heavy textures, high poly scenes, and multitasking with other demanding applications. For storage, the primary, it's recommended to have 1 terabyte, but you can have 500 gig also. But the 1 terabyte allows for fast boost times and application responsiveness. Secondary storage, additional large capacity SSDs and HDDs for project files, texture libraries, and cache data. Power supply. Choose a reliable 80 plus certified PSU with enough wattage headroom for CPU and GPU loads. Cooling, maintain a good airflow with high quality fans or liquid cooling solutions to handle prolonged rendering sessions. So this just means that a lot of us have our gaming laptops and they have fans on the bottom of it, and that's to help with the cooling, because some of the demand that is put on the PC itself, it needs some sort of cooling. So if you realize every gaming laptop has that. Build quality, a well constructed case with proper thermal design ensures long-term stability under heavy workloads. Also, for the CPU or processor, multi-core versus high clock speed, CPU rendering, many core processors like AMD Threadripper or Intel Core i9 or Xeon Excel for final frame rendering. So these are the highest that they can get, but you can also get i7 if your money probably can't get the i9 or the AMD, but they want at least i7 minimum so that they can be able to put do good renderings, because a lot of the rendering software is actually check the laptop specs before it allows you to open it. So if it's too low, it will tell you that you can't run the software on the laptop because it might not be able to manage it. GPU rendering and viewport performance, high clock speeds are equally critical for smooth real-time previews, simulations, and modeling responsiveness. For the graphics card now, prosumer GPUs, cards such as NVIDIA GeForce RTX 3080 or 3090, or AMD Radeon RX 6900 XT. So now I think the NVIDIA GeForce is at 50. It's now 5080 and 5090, but you can use minimum 5050 or 5060, but for the highest performance, you don't want between 3070 and 3090. But as I say, if your money doesn't allow it, then you can get 3060 or 3050. Workstation GPUs for mission critical tasks requiring stability and certified drivers. NVIDIA Quadro or AMD Radeon Pro cards are better suited. Advantages of real-time rendering. Faster preview. Changes to lighting, materials, and camera angles are reflected immediately in the viewport, making it ideal for client presentations and faster design processes. Quicker render times for image and video animation output, and interactive. So it just means that you can actively change materials, lighting, camera angles in the software at the same time, rather than offline where you have to set the scene and then you render the scene. Allow the users to move the viewport live, giving the ability to walk through scenes to make quick changes to lighting and materials and add assets, etc. Use an RTX card to make visuals more realistic with ray tracing and faster AI enhanced DLSS. User-friendly typically has a more user-friendly interface, requires minimal manual parameter input, lower hardware requirements for some software. So as it said, the real time allows you to move through the scene in real time and put in any assets or any materials that's needed in the scene, after which you can generate quick views in the software. Disadvantages, however, limited realism. Offline rendering perform better at producing realistic results, better lighting, acoustics, global illumination and reflection. Hardware demanding. Requires a powerful GPU with a high RAM to handle complex scenes and higher resolution PBR textures and HDRIs. Less control for advanced effects such as advanced reflections, acoustics, and global illumination. So as we said before, the specs or specifications, if your computer is not at a certain level, you can't really use real-time rendering softwares because it demands so much of the PC, and that's the setback with it. I think for offline, you have the scene and it just renders the scene for you. It might take some time, but you don't have to go through the model and put in any assets or anything of that nature. Advantage of offline rendering. High realism produces the highest quality results, accurate lighting, shadows, reflections, and material properties. Handles complex scenes better, large geometry, and heavy materials, as well as complex simulations. For example, smoke, water, acoustics. Mostly used in firms of final visualization, software is flexible and allows for CUDA processing, both GPU and CPU, as well as CPU rendering. Performs better in interiors and close-up renders that require high quality details. The disadvantages, however, longer render times, even with a strong CPU and GPU, renders can take minutes to hours per frame. So as sir was saying last class, for offline, you might have a render that might take 8 hours and you have to leave the computer on, or some might take 15 hours. So that's a disadvantage if you're under time or you're under, yeah. Non-interactive, small design changes have to be re-rendered, less immediate than real-time editing. So if you make a mistake in the scene, you might have to change it and then re-render it. Not like real-time where you can actively change it. So it's hardware intensive, needs a lot of RAM and CPU or GPU power for larger projects. Steeper learning curve, less beginner-friendly than real-time rendering engines. Requires more user parameter input. So this is I guess a comparison with real-time render and offline. So,
All right.
sir, so I've had actually a live demonstration that Regina is going to
Oh, okay, cool.
for the class to give them an understanding between real-time and offline. So we'll allow him to share his screen and just give us an explanation on,
Okay, cool.
Yes, sir.
Hello?
Yeah, man, I can hear you. But are you in the same room with
Yes, sir. Yes, sir. Yes, sir.
All right, cool. I can hear you good now. What's up? Go ahead.
Hello? Yes, sir. Can you hear me better now?
Mhm.
Oh, shit. Hello?
Mhm.
All right. So this is a quick demonstration between real-time and offline rendering.
Mhm.
So first I'll show a demonstration in our real-time software, which is D5. As you can see, the interface for D5 is more interactive, meaning you can manually move around the scene and you're still getting a rendered image. And the materiality, you can change the materials of various surfaces quicker by simply adding it to the surface and it changes it instantly. And the similar scene inside 3ds Max, which uses Corona for rendering. And for this software, it's more complicated in terms of materiality, being that you have to manually move this.
Oh, the zoom bar. There should be a hide button there. Um, Usually, no, it's the green. There's a little green tab below. You see that little green, like a little.
Oh, all right. Yeah. So with this software, you have to basically set up the materials manually inside a material editor, and it's similar to the other offline renders such as V-Ray and Arnold and other stuff like that, where you have to manually like attach the material images to this central material object that the rendering software interprets as the materials, so stuff like the base pump and the base color, displacement, all those stuff. And then you would basically have to set up the lighting and the camera and all that stuff manually before you can render the image and get the final result. So this right here is actually the sunlight that you would have to set up manually. Like you have to change the angle and all those stuff. And this will be the camera right here. So you have to change that field of view and all those stuff. And then the final result would look something like this.
Are we attempting to render while share screening? You can. Hopefully the computer will survive. It's surviving. That's good.
Yeah, so this is the interactive render. So this is how it processes. It processes the image, where it uses the pixels and it bounces the light around the scene, and that's called passes, where the software repeatedly simulates like the light movement and the physics and all those stuff, and replicates it until it gets it correct, essentially. So that's the reason why rendering in a offline rendering engine takes so long, because it uses a different approach to rendering as opposed to the real-time rendering engine that basically captures the scene as is and just optimizes the image until it reaches a desirable output. Yeah, that's it, essentially.
All right, good stuff. Good stuff. All right. Yeah, you guys were approaching the red zone in terms of timing, but good information. All right. So each group is going to pose a question, right? So there are two presentations that just went by. There are there are 8 groups that are in the audience now. So 4 questions should go to topic 1 and 4 questions should go to topic 2. All right, guys? All right. But before you ask your questions, and by the way, I'm going to give you guys limited time, right? Because time is going, right? So before you go into the questions, I'm going to comment first. So firstly, on the first presentation, right, so good information. I noticed that you kind of showed all your information pretty much on the slides. So it's good that you did that you had all the information. Interesting thing is, I mean, nowadays information is not the hardest thing to come by, right? As a matter of fact, we probably have too much information now from all sorts of sources. In any case, it shows that you had the information. What I can say, so in the area of the research depth, right? First thing I have to address is the trick with your topic is that modeling techniques, a lot of modeling techniques are, what's the word? Made up. And when I say made up, it's almost like if I ask you, like, if I ask you what type of plant is a particular type of plant, and you would say and let's say that it looked like a palm tree. You might say, oh, is a palm tree kind of plant, or is a coconut tree looking plant, or is a tropical plant, meaning that those are like terms that we kind of come up with as a society, as a culture, as maybe somebody in the general area to describe the type of tree. But there is like a scientific name for it, right? Which I don't remember, right? But so it's the same thing for modeling. 3D modeling has been around for a while. So people make up types of modeling every day. So I can say that I am SketchUp modeling. And if you Google SketchUp modeling, you will say, oh, SketchUp modeling is a type of modeling where you blah, 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 blah. If I'm using, for example, BIM modeling, the reason I bring up that example is, I mean, BIM modeling, yes, you are using a BIM software, but BIM modeling isn't like BIM modeling is a type of parametric modeling. So there are certain core types of modeling. And then you have different types. Somebody would say, oh, I'm BIM modeling or I'm CAD modeling. But there's no type of modeling called CAD modeling or BIM modeling necessarily. So that was the first thing. Now you did cover some major type of modeling, which is good, like parametric modeling, spline modeling. What was the other one again? And then you had, but there's also something else that was confused as well. Wireframe modeling. So wireframe is not a type of modeling. It is a way of representing modeling, right? So almost every modeling software can show you the 3D model in what? In wireframe format. All right, you guys notice that? Topic 1, you with me? Let me get that. You with me, topic 1, people? Yes, hopefully I have lost you.
Yes, sir.
Right. So, right. So whether you use SketchUp, any BIM software, almost all 3D software can represent the model to you in a wireframe format. But it doesn't mean that wireframe is a type of modeling. It is a way of representing a model, right? Now, and you said primitive modeling. That was another type, right? So the main types of modeling that you guys mentioned, where you hit the nail on the head, is procedural modeling, primitive modeling, and spline modeling, believe it or not. Most of the software that we use in architecture, Revit, any BIM software, SketchUp, not really SketchUp, but parts of it are included. AutoCAD, most of the software that we use in architecture is a form of parametric modeling. And the reason that it's called parametric modeling is because it have parameters. So for example, when you have a box, there's a parameter to set the height of the box, the width of the box. When you draw a window, right? You guys have been creating that model in for your major project. When you draw a beam, right? How do you adjust the beam? You have a parameter that you choose the family, you choose the height, you choose the width. Those are all parameters, hence parametric modeling, right? But the slang is BIM modeling because we're using a BIM software. But BIM modeling isn't necessarily I want to say scientific or official modeling type. So for example, spline modeling, that is an official modeling type because you're actually modeling using a spline, and that is actually pretty cool. I've done some spline modeling in the past, and most of the examples that you give is correct. You know, they use it a lot with organic. They use it a lot with organic shapes and that kind of stuff. And we'll go into the details. And primitive modeling, that is also a good one as well. Primitive is like you're putting boxes together, boxes and spheres to form a shape or whatever. So a lot of programs Some 3D programs, they just give you primitives and you have to put those shapes together to form something, right? And there's some other types of modeling as well, but I'm not going to go too deep in it. I just wanted to touch on that. So I don't want you guys to confuse wireframe modeling, because that's not a type of modeling. And what was the other one, guys? Let's see if you're listening. What was the other one?
Sir, BIM.
Exactly. BIM modeling. Good, good, good. All right. So with that said, which group has their first question for topic 1? What are the different types of modeling?
Sir,
All right. State your group.
I'm from group 4.
Topic 4. All right. Go ahead, topic 4. Who you
So
asking the question to?
to the group in general, because I don't know who will have the answer for me.
No, but which one? Which topic? Which types of
Which
3D
one?
modeling are real-time
3D
versus
3D modeling, 3D
3D
modeling.
modeling? All right, cool.
They went through a couple different types of applications that do 3D modeling. But if you had to recommend at least 2 to someone who's just beginning architectural 3D modeling, which ones would you recommend and why?
When you say beginning architectural, you mean somebody who have
Someone
graduated from
who's
school and they're about to start, or somebody that's about to, like, you're in second year and you're about to venture into 3D modeling?
that one.
Okay, all right. All right. Topic 1, people. Which type of 3D modeling would you recommend to somebody who is an architecture student who is about to start modeling or to start that area in their
And
studies?
why?
Okay, and why?
I feel like okay, one of the applications that I would recommend for a beginner is SketchUp. I feel like SketchUp is very easy to grasp. In terms of the push-pull method, modeling method that it entails. So I would say SketchUp for one.
All right, hear what? You're supposed to mention 2, but I'm going to eat away a piece of your question. Who asked the question again?
Me, sir.
Oh, sorry, I don't have my thingy up. Oh, where are you? Oh, it's over here. Yes, right. So you said mention 2, but here, I'm going to eat half of your question because I want topic 1 to tell me, all right, if you recommend SketchUp, so what kind of modeling is SketchUp? You mentioned parametric, you mentioned the ones that are actual type of modeling. You mentioned parametric, you mentioned primitive, and you mentioned spline. Or it could be others. Are you not sure? It's okay if you say you're not sure.
Sir, can you repeat the question? You broke up for us, Elizabeth.
Right. So the question was, what type of 3D modeling would you recommend? What 2 software? So you mentioned 1, which is SketchUp. So I'm asking, okay, what type of modeling is done in SketchUp? Or do you think? It's okay to say if you're not sure.
Sorry, can you hear me?
Yeah, go ahead.
I would say
All right, well, I'll make the group member answer. Oh, no, you are a group member.
they can answer, sir. They can answer.
You can answer too, you know.
Oh, I was saying that SketchUp, because it's we say simpler to use than most softwares, will be a part of like primitive modeling.
Okay, cool, cool. The truth is that a lot of software, they don't necessarily have one dege type of modeling. They will have like a main one, and then you can do others. So for example, 3D Max has spline parametric primitive modeling. What name? Revit only has parametric modeling, right? So SketchUp, it have a little bit ounce of primitive modeling, but SketchUp is primarily what you call polygonal modeling, which that is another modeling type that wasn't mentioned, right? So polygonal modeling is when you build up a model by polygons. You know, primitive modeling, you build it up by shape, box, circle, square, prism. Polygonal, you build it up by actual polygons. You draw the polygons and put them together. So SketchUp uses that as the primary main mode of modeling. So yeah, SketchUp is a good recommendation. All right, next question, quickly. We're running out of time. Let's keep it quick. So that was group 4, topic 4. So that was topic 4 question. So topic 4, you don't have to ask any more question. Moving on. All right. So here's what I'm going to do. I'm going to call the topic, and then you have 10 seconds to ask your question. So topic 3.
Yes, sir.
All right. What's your question, topic 3?
For which one, sir? The first group or the second group?
Anyone. You can ask any group.
Okay, first group. What would be a disadvantage of 3D modeling?
A disadvantage?
One
Okay.
disadvantage.
Yes, sir.
You sure they never said that in the presentation? Did they say that in the presentation? Okay, go ahead. I'll make it pass. Go on.
Okay, one disadvantage of 3D modeling is that it's very costly. It can be very expensive, especially depending on the software that you decide to use.
All right. That question was, you kind of script through with that one, group 3, kind of. Because they did mention something towards that. Remember, guys, you're not asking the question to test if they know what they just presented. It's not a test. I assume when you present, you know what you present. You're kind of just asking a general question out of curiosity. Maybe it's to expand on something or something like that. So you're not testing them. All right. All right. Group 4 went already. Group 5. Group 5. Group 5 going once. Group 5 going twice. All right. Group 6. What's your question? Oh, wait a minute. I just remembered something. I think I only went through the first presentation. Oh, the first presentation. I should have right, because I talk about both presentations and then we take questions. All right, so group 5, you have a little bit more time because I only gave a review for topic 1. All right, so topic 2. All right, guys. Firstly, I must say, which program did you use to do your presentation?
Sure, I use Canva, but
Canva.
I utilize like my own design. So basically, you're not going to find that per se on Canva.
Right, custom. Got you.
Yeah, custom.
Got you. All right, so what I liked about that presentation is that I like that you put bullet points, because the way our presentation is supposed to work, guys, and this is for everybody, you put bullet points and then you keep your presenter's notes. So this is something that you should take with you even when you're presenting your design studio, right? Try to only put bullet points, because like when you have a presentation up there, the persons in the audience can literally only read a 2-line bullet point. Like if it's like 10 lines, you kind of like the person only going to skim usually. I mean, I guess if it's a technical presentation, then maybe, but usually you want to just put a few bullet points and then you have your own talking points separate. So I like that you guys put bullet points and stuff. And the general design of the presentation was very good. It's simplistic, which is good. In terms of the depth, I like the fact that you did a demonstration at the end. That really kind of takes it home. I think that was a great example where you can see the real time and the offline. I mean, maybe I should save my questions because you guys should already have questions, but I will save my questions till after. But it's almost like I want to ask, why would you use one over the other? No, actually you did kind of cover that when you would use it. But what I want to say is, you mentioned that one of them looks better, right? And I should probably ask this question. In the audience, this is not for the group. Which one did they say look better? The real time or the offline? This is not for the group members, this is for the audience.
Offline.
The offline. Okay, good. That means I listen. But the reason I bring this up, I would argue that nowadays, with the advent of very expensive video cards and new programs like D5 and all of that, in your example, for sure, the offline render of that scene looks much more realistic than the D5. But there are certain circumstances and software like Unreal Engine, for example, like Unreal Engine is able to pretty much match the quality of offline rendering, right? And I'm going to say visually match it. Because the truth is, nowadays the question is not which one look better, because both of them look nice. Like a real-time rendering engine did Mandalorian. Anybody watch Mandalorian series? I don't think it's a Netflix thing. It's Star Wars. Anybody watch it? And I think one of the Star Wars, I don't remember which one. No Mandalorian fans in the house? Star Wars fans? Which other movie did they do with it again? Oh, they do so much advertisements with Unreal Engine. Like car advertisements, like the new Lexus or the new whatever, when the car driving on the road and all those fancy things. So what I'm getting at is that nowadays, visually, real time is catching up or have caught up to offline, but not generally. So for example, when you use your D5 or your Twinmotion, it's not, I would argue that you can, for those of you who are in the industry, you would probably pick up that, this V-Ray render look a little, like if you compare it, like the example that you gave with the two cars, like, they pretty much look the same to me. I don't know. What do you think, group members? Topic 2. Did one of those cars look better?
Sir, you asking us, sir?
Yeah, I'm asking you guys.
What question is?
Say again?
What was the question?
If one of those, you showed an example where you showed 2 cars, one is offline and one is real time. Which one did look better to you? Like, could you identify, you know, if you didn't have the titles there?
Sorry, the one on the right. Look better.
Throw it up back on the screen so that other people can see it. If you can just jump back to that slide. Because there's a point important point I want to get across to you guys.
1 minute there, 1 minute.
All right, cool. Right. So the idea is that, well, in my opinion, when you look at it, I'm like, okay, but these cars look the same way. Like in the example at the end, I could see where one looked different than the other.
Sir,
But
it's really just lighting. Like the
exactly.
one on the right is more realistic in a way, versus like the one on the left isn't as like, in reality, a car isn't as shiny then, if you get what I'm saying. Even with the like
Right.
how the light from the headlights would look or appear. It's
Right.
just
Got
really
you.
lighting.
Right. So of course now to the untrained eye, and when I say untrained eye, I'm not even talking about the man on the road. I'm even talking about first year architecture students, people in the industry. Like they would say, okay, yo, these 2 things look the same. So I want you guys to think about a different word. The race now is not the race for realism because everything look real. It is accuracy. Because I like how you mentioned the word lighting. And the reason why I put the word accuracy there is because accuracy in architectural viz is not as sought after as with Hollywood, right? In architecture, you want it look nice. I want to use the word nice. You know, real don't always look nice. You know, we want people to be excited about this building, this design, this whatever. And when you render it and it render photorealistic and it have that real look, it look nice, even though it might look computer generated or not as real as this other image. It's still within the realm of a good visual eye candy. But in Hollywood, I remember which movie I watched there. I watched a movie with that dude. I don't remember. That dude. Anyway, the point is that the dude that came in Ice Road. And there was a scene where the vehicles were on a cliff and the truck run the other vehicle off the cliff. And there was a scene where the vehicle is falling off the cliff, and I'm like, yo, that looks horribly fake. And when I say horribly fake, meaning that it probably looked better than this rendering that you're seeing on screen. But in the context of you watching a movie, you know, whatever movie it is, when something don't look ultra real, like cause you can pick it up psychologically when something look fake, you know, like a fake special effect or something, it just break the immersion. You're just like, you know. But in architecture, it's different. Like it's not, so we're not chasing accuracy in architecture really, right? Of course, there are use cases where maybe, you know, is a blockbuster architectural piece, then fine. But I'm saying generally, I'm saying this to say I don't want you guys in architecture school to spend all your time chasing the realism because everything look real by default. And where the real edge is with offline rendering is accuracy. The way that this light bounces off of this thing, it is accurate. And there's a word that you use in your presentation. I don't remember is which one. I think it's Maxwell or something. You use the word non-bias lighting. So that term non-bias simply means that no corners cut. I worked out the entire calculation of this light ray And the way that this light bounces off of this and bounces off of that, it is mathematically correct. Even if it took me a whole day to work out that equation. So that is non-bias. Whereas bias is just like, yeah, man, if they're so dark, then here's a going kind of dark. And it just going to take a shortcut. So most of these offline rendering programs, what it touts is that it's unbiased, meaning that it will be accurate. And that means time. But for Hollywood, it matters because when I came out of that movie and like a person say, yo, you like the new Ice Road movie? I'm like, no, sir. And that translates into millions of dollars lost for Hollywood. So they need it to be very accurate, not just realistic, but accurate. But in architecture, we need it to be nice, not necessarily super accurate, at least not to the point of Hollywood. All right, so that is my 2 cents on that topic. So I think I mentioned all the points. I think I did. Yeah, I have which, but these are questions. I don't want to give away questions. So let's just jump into the questions. All right, so back at group 5, topic 5. Anybody from topic 5 going once? Going twice? Topic 6. Any questions from topic 6? Remember, guys, the 5% is based on the questions that you ask. Yeah,
Can you hear me?
yeah, man, I can hear you. So this is a question from
topic 6.
6, right? And who are you asking your question to?
3D modeling.
3D modeling. All right, cool. Go ahead. This is the second question for 3D modeling.
So I'm asking, like, would you recommend Blender for architectural graphics? Because I know in Blender you cannot export 2D rendering. So if you want to like plan to Blender or they just for rendering.
So the question is, would you recommend Blender for architectural, for the industry, I mean, as a whole?
Like even for school, because they cannot export like plan views to scale.
Right. Got you. Yeah. So would you recommend architecture? Would you recommend Blender for even for use in architecture school or maybe architecture on a whole? Because Blender doesn't have architectural specific tools. Would you recommend it? And I want to add a piece to that and why not. Go ahead, topic 1.
Are you hearing me, sir? Or everybody hearing?
Yeah, man, I'm hearing you.
I would say it could be used because at the end of the day, it is a 3D modeling software, but at the same time, there are easier, more manageable softwares that can be used. And like she said, there are lots of limitations in terms of what can be exported, etc. So especially if you're beginning, I would say no. But if you could find a way to maneuver it, then who's to stop you?
So what would be what is the advantage, if any, to use Blender in there? What do you think, based on your research? Let's say that you're going to a firm that say, you know what, we're going to use Blender. And you're trying to come up with good reasons why you should use it. What would be those reasons? If there are any.
So anybody can answer this?
This is for, you know what? Yeah, anybody can answer.
Well, so it's free.
That's a good one. It's free. Apart from the fact that it's free, by the way, so I mean, I used to use Blender. Blender is pretty advanced. And we used to use 3D Max back in the day. not so far back, at least like even 2016 or so, we used to 3D Max was a part of the curriculum, and 3D Max is just as complex as Blender. You guys saw the demonstration earlier. And the reason why you use complex software is options. If you've ever wondered, like you say, you saw the example from topic 2 earlier, and you see that example with the room, and when they rendered one in Corona it was, right? And you're like, wow, that looked nice, man. And you look on D5 and say, I mean, D5 look nice too, but it don't look as real as the other one. But apart from that whole realism thing, because as I say, nowadays everything is real. So that's not the aim. You use the complex software to get options. So like, for example, you're using Twinmotion, you can have you can pick from their library a person swimming. But suppose you need somebody jumping off a diving board because the diving board is the highlight of your design. You know, you have garage doors, but suppose you need a specific garage door because that is the highlight of your design. You know, suppose it's something very unique about your architectural design, like the building transforms or open up or does something that the generic building components don't do. Then if you're using any of those real-time typical software, you're going to be out of luck because the D5 and the Twinmotion and those things, they have built-in typical stuff used in architecture. And once you start to go deviate from the norm of how things work, that's when you're going to start seeing the limitation of using those programs. So the reason you use a Blender or a 3D Max or a Maya and these complicated software is because you have more options. When your mind starts to go into the Haddad level and you're doing all kinds of madness, you're going to need a much madder software to stick with you. All right. 6 more questions to go, Seiko. No, so we have topic, so we did 3, 4, 5. We left with two groups didn't answer. Whether I just did topic 6 or that was 5? No, that was 6. Good. So that would mean 7, 8, 9, 10 need to ask questions to the other group. Or at least 2 of those questions need to go to the other group because we have to balance it. All right. 7. Question from topic 7, from group 7. Going once. Going twice. And all right. 8. Topic 8. Question from topic 8.
For the rendering, for the 3D rendering group.
Yeah, go ahead.
Does the rendering quality affect the file size?
Does the render quality affect the file size? Okay.
Oh,
I will accept that. Go ahead. Anybody from that group can answer.
Yes, it does, because like
Give me an example.
yes, sir. So basically, depending on the output, so if it's 4K versus 8K or 16K, like that's the actual size of the image. So the bigger the image, then the bigger the file size, essentially.
All right, cool. I want to add a little bit more to that. When you are rendering, I would say currently one of the advantages that offline rendering has over real time is that offline rendering can produce what's called render elements or render passes, right? So this is going a little bit into advanced visualization, but basically the way how Hollywood, if you guys ever watch the making of anything, you know, making of Matrix or the making of Lord of the Rings or any making of anything, you realize that when Hollywood doing stuff, them do stuff in layers. So you see, for example, them put the people in a green screen and them put that on a background layer, or them model the dragon in the air, and then they have the mountains in another layer, and then they have the foreground in another layer. It's whenever offline programs are rendering, they have the option to render layers. And that's another thing that makes offline rendering so realistic, because like you have the option to do that. You have the option to render just the trees, just the people, and just the cars. So that means your one picture is now 3 different pictures in parts, which means it's going to be larger. What's the advantage of doing that? Anybody? It can even be top the group. Anybody in the class? What's the advantage of rendering it out in layers?
I would think that the advantage of rendering out in layers is to possibly, one, decrease render time, and two, like do selective rendering, I would say. So it's like you said, if you want to just render the trees and you want to hide certain elements, you could probably do that.
Okay, yeah. Those are good reasons. One of the main advantages on top of those reasons are you get more customization. So if you render just the sky, you know, and you need to change the sky to a different sky, you can just re-render that layer alone. You know, if you render
Sir,
just the people and you want to change it. Yeah, go ahead.
sir, it's almost like just in any design software, even just Canva itself, the fact that you're doing it in layers, you can easily remove something, as you said,
That
customize
is
as well.
true.
So
That is true.
basically, I would say even in rendering too, when you do it in layers, you can remove something if you don't like it. You can easily replace it. Yeah.
That is very true. So now you have some real-time programs like the latest version of Lumion, they allow you to render out in layers. Like, so I'm not talking in the program now, you know, like when you have people on a layer and you have your building on a layer. I'm talking when you click render and you get the image or you get the video. Like in, you know, the highest, like in Hollywood style, they will render out an entire scene and it's just the cars driving. There's nothing else. There's just transparency. And then they render out the entire scene and it's just the people walking. So to render out a specific layer is usually a feature of an advanced software. You know, but it's, you know, that gap is closing because Lumion can do that now. I think D5 can do it. And I don't think, I don't really count those features because eventually all of them going to do it, you know, eventually, you know. But yeah, coming back to the original question, that's why the file size can be larger because you have more options in offline rendering to do all sort of fancy output, right? All right, so that was topic 8. Yeah, that was group 8. When you're asking questions, I'm going to call your group, and when you're presenting, I'm going to call your topic, but the number is the same. All right, so group 9. Question from group 9. Went once, went twice, and question from group 10. Anybody here from group 10? Went once, went twice, and all right. So that would conclude the first presentation class, right? So remember how this goes, guys. When we have the presentation only gives you, out of the 20% for your grade, you get 15% from just the presentation and answering questions. The other 5% comes from the questions that you pose, right? So if your group posed a question, you're lucky in that 1%. So the next time we present again, we're going to do the same thing. And it's going to be topic 4 and 5. Right. Before you go, it's drum roll time, right? We are going to unveil topic 5 and 6. Do we have topic
Sir,
5 group members here?
sir, quick question. Do we send the presentation to you or
Yes. Yeah, you submit it.
submit it on the website?
Right. There's a slot for it. So if it's Canva, just export it to like a PDF or something.
Sure,
Alright,
sir.
okay.
But should each of us upload it or just one person in the group?
No man, one person.
Okay, sir. Thank you.
Mm-hmm.
Excuse me, sir, for the tutorial that happened this morning, when will that recording be uploaded?
Today, like like give it like another hour. So I normally put up 2 of them same time. All right. So today, because I have to encode it and upload it.
All right.
Mhm. All right. So, do we have topic 5 people here? Topic 5? Anybody from topic 5?
Yes, sir, we're here.
All right. Good. All right. Topic 5. Oh, I have to do this quickly because time is going. All right. Drum roll for topic 5. Ta-da! How can we incorporate AI in the practice of architecture? All right.
Excuse me, sir, are you sharing your screen?
Oh, my bad. I forgot I stopped sharing earlier. Here we go. And here and here. Right. So topic 5 is how can we incorporate AI in the practice of architecture, right? And let's give it a while to open this thing. Topic 5. Topic 5. Here we go. Right. So you guys are going to discuss the application of AI in the practice of architecture. How can we incorporate AI in the practice of architecture, right? So, of course, this topic can take you down a rabbit hole, guys. So you're gonna have to try to not slide down the rabbit hole, right? I want you to stick to architecture, right? We know that is a simulation of human intelligence. That's basically what it is. And we know that there is all sorts of facets of AI, anywhere from, auto face detection stuff, social media, algorithms. It's in everything. And it is just under crazy development now. It is in everything. So what I want you guys to do,
I think there's this
now,
misconception that
like for example,
architecture
I
comes
want
into
you to
being
stick
as this kind
to
of single.
looking at how people can use AI. Like this is a great channel. You guys supposed to know it. I think it's 3060 or so it name. And like this guy show an example of how he uses AI, particularly in architecture and design, where he plugs some of his images in an AI program and then uses it to generate, even if it's not exactly logical, but generate inspirational images that will help set the tone for what he's trying to create, right? So there are different ways, so I want you guys to kind of stick within the realm of architecture, right? And I don't want you to stick within the too technical realm. Like, for example, yes, we can use AI to work out how much bedroom can fit in this space and all of that technical stuff. But I want you to also think about it as it relates to design as well, right? What are some of the applications of AI and how can it be used in architecture? Of course, what's the pros and cons of using AI, right? And of course, what is AI itself? As I say, guys, don't slide down the rabbit hole. You only have 15 minutes, right? Are there any plugins that can be used in, not just plugins, but how can it be used in conjunction with the programs that we use today, right? And give us some examples of AI work in architecture, right? Yes, we probably want to look on the history of AI, but as I said, don't go too deep because AI is very broad. I would kind of very briefly summarize the history of AI and more stick to how it has been used in the design area. I would kind of stick to the design field. Don't go too deep down into how it works because you can get lost in a deep web of how it works, right? But I want you to kind of bring it home to like tell me some of the different tools that we can use. And talk a little bit about the ethical use of it, right? It would be great if you can have any kind of demonstration. What about in architecture school? Like, how can it be used in architecture school? As I said, stick to more design, to the design part of AI. All right, guys? So that is some quick tips for you. All right? All right. What about topic 6? Anybody from topic 6 here? I think
Yes,
Evelyn
sir.
is here. All
Yes, sir.
right. All right, Evelyn. So a drum roll for your topic. All right. I don't get any drum roll from the start of the class. All I get is crickets. All right. All right, topic 6. Discuss the use of 2D drafting versus 3D BIM for construction drawing production, right? Right? So, as you know, when you guys do construction drawings, or we call it working drawings, we can generate them from 2D drawings, or we can generate them from 3D BIM, meaning I think some of you said that you still use CAD to do drawings nowadays, and some of us are using Revit. We're actually learning Revit here. So, here we go. Right. So for your topic, you're going to discuss the use of 2D drafting versus 3D BIM for construction drawing production, right? Traditionally, 2D drawings was how we did things. We started from hand drawings, which was also 2D, but then we went to the computer. And drafting, we still do drafting nowadays, right? We're just still learning how to transition to BIM. But during this transition, things can be tricky, right? So I want you guys to compare these two methods. You know, one of them, you're drawing lines, you're offsetting, your what the tools, your fillet, trim, all that stuff. And then the other one is just about parameters, wall height, wall type, you know, what level is this wall on, and all of that stuff. So I want you guys to kind of, we're going to compare them. And we want to look on, you know, the disadvantages and the impact of the industry. Like, what is happening in the industry nowadays when switching from 2D to 3D? Like, I'm sure you can even find firms nowadays that are in the process of switching. What are some of the challenges they're going through? You guys are actually in school in the middle of this transition. Most of you are going to come out of school knowing BIM, but you're going to go into a firm and they're going to be using CAD. They're going to be using 2D. So how do you think that integration process can work? right? For people who are using CAD, what are the type of 2D software, 2D CAD software? When I say CAD, I don't mean AutoCAD, I mean computer-aided design. What are some types of computer-aided design software, 2D, and what are some types of BIM software? So I want you to tell me those different types. And how does 2D CAD and BIM, how does each of those add or minus from the efficiency of doing construction drawings? Because I'm sure there is plus and minus on each, right? And I want you to talk about how the industry has shifted, or how is it shifted? You know, speak a little bit about that, about the transition from 2D CAD to 3D. You know, the main things that separates them. What is the core thing that separates 2D drafting from BIM? Right? I want you to nail that on the head, because some of us use BIM, some of us use Revit, but we also use CAD. You know, sometimes we combine them together. So what is the main thing that separates them? And I want you to compare the complexity, because I hear the arguments on both sides. Some people say CAD is easy and simple and straightforward. And other people say, you have to be insane to use CAD. Why would I draw louvered windows with 54 lines and each of those lines have to be offset each time when I can just click a louver window and set the properties and say, give me 10 louvers? But on the other side, people who use CAD always say, I don't want to spend all my time in properties dialog boxes, choosing wall height and wall thickness, and I just want to draw a line. It's so simple to just draw a line rather than diving into properties. So that fight is even happening today. So I want you to speak about that. And are there ways to combine 2D and 3D? Are there offices that can do that? As usual, I want you to carry it home to architecture and to CSA. Do you guys see any advantage or disadvantage with using a 2D drafting program versus a BIM program? How do you think, how speak to that in an architecture school? How does that work? Do you think using Revit is too complicated, or should we stick to just doing 2D drawings? All right, topic 6, you following me?
Yes, sir.
Right. So I hope you take some notes. Those are some of the discussions that I want you to focus your research on. All right. All right. So as usual, we're going into the overlap mode now, guys. So every topic has 2 weeks. So next week we will be doing topic 3 and 4, right? And then we're going to unveil topic 7 and 8. All right. So if we're ever getting confused, please check the timeline on the on the class website. If you're confused about what topic, when are we presenting again, check the timeline, guys. All right. Because a lot of things are overlapping. All right, that is it for class today. We're gone a couple minutes over, but not too bad. Great presentation. Remember, I just needed to submit, just one person upload the presentation and that's it. All right. And I think you will get your grade. I think your grade should go in. Well, remember that when I'm grading your presentation, that's only graded out of 15. The other 5% is going to be based on, did your group ask a question when the other group was presenting? All right, so that the rest of your grade won't come in until everybody has presented. All right. All right, guys, any questions before you go?
Yes, sir. Sir, I'm currently not in a group.
Oh, all right. Because we're out of time. For those of you that are not in a group, please message me. Who told me just now?
Sir, McCoy, sir. I also sent you a message as well.
Okay, send it in WhatsApp. Don't send it in Zoom because when I close the meeting, I'm not going to see it. So those of you who are not in a group, send me a message. I'll place you in a group. You can only go in a group that hasn't presented yet. All right. So, right. So the group that is presenting next week, you wouldn't be able to go in that group because they have already started their research or whatever, but you can go into the group that will be presented 2 weeks.
Sir, can you provide a number in the chat, please?
Oh, sure, no problem.
Excuse me, sir. I have a question as well before you end. I was checking out the grades that you posted and my ID wasn't there. I don't see myself.
All right. If you're not seeing your ID, that means that means for some reason I don't have it. Did you register for the class website?
Yes, sir. My name is there.
All right, good. Oh, hold on. All right. Post it in a message and send it to me. All right. Just send me a message and I will check on it. I'll add it to my list.
Okay, no problem.
Because more likely your work is marked, but for some reason I haven't entered the ID. But from your name is on the class website. Maybe the information I don't filter it over fully yet. That's why you're not seeing it. Was it recent or a long time?
Repeat that, sir, as in like when I registered for the class?
Yeah.
Long time, sir, since the first day.
And from the first day, you say?
Yes, sir. I even double checked it and my name is on it.
All right, cool. Yeah. All right. I see some more questions. Ethan. All right, okay. Let me check on that and see what's happening. Gifford.
Yes, sir. You hear me?
Yeah, man.
All right, go. So, I did this course last year, I think. Yeah. Can I use about the same drawings that I used?
Last year you said, right? Yes, I remember. Yes, because it didn't change, luckily.
Okay, cool.
So sure.
Sure. When is class finished, sir?
It finished now.
Oh.
So I only we do in the morning everybody comes for the morning practical and then everybody come for this lecture.
Tutorial?
Yeah.
All right, cool. All right. Wait, I need about 5 minutes.
You need say again?
I need 5 minutes of the time after.
Oh, you want me to go in like a breakout room or something?
Yeah, I would appreciate it.
All right, no
I don't
problem.
know if I have to wait on the
Right. All right, let me check. Is there any more questions apart from Gifford?
Sir, I can have a question.
All right. Generally.
Sir, I had a question. Kind of like a long shot. It was just like a question based on my elective because it's kind of in your realm, introduction to multimedia design. So I didn't know if you knew anything about it because I haven't heard anything about it. So I was just gonna ask you if you knew anything.
Multimedia, that's the one that you do with Skit?
Sir, I don't even know, like, it popped up on my Moodle, but there's no link, and now it's saying that So
I remember there was
the teacher the teacher, it seems that the teacher that was there last year, I don't know if you know him, Lushane Jones, Mr. Lushane Jones or something like that.
He's not CSA.
Oh, well.
I don't think he's CSA. That's why I think he's over animation or is over skit, like computing. It might be them that put that on.
Oh yeah, it's an elective, so I was just gonna ask you. It's just a long shot because I need to know what's going on, but I don't know.
I'm not sure. And that's the thing, you know, because you know you have some elective that is run by CSA,
Yeah.
which you know would probably know the lecturer that runs it. But the ones that run by another faculty, no. Yeah, I'm not sure.
All right.
But
Thank you, sir. I was just gonna ask.
yeah, man. As usual, Miss Baker, she know everything, all things. So see if she know like the person that doing it. But it sounds like it coming from Skip.
Okay, sir. Thank you.
Sir,
Yeah, man. What's up?
one of the persons who joined today, they asked my group before if it was okay to join our group. We're group 4, by the way. I don't know if that's okay with you or not.
Oh, you're presenting next week.
Yes.
I mean, if it is okay with you, cause you know it's kind of in the middle. So if you guys are good with that, then sure. Tell me the name.
Javin Maitland.
Okay.
Mate Land. Yeah.
All
Thank you,
right,
sir.
cool. No problem. Any other question?
Yes, sir. Is your contact info on the website?
For me?
Yes.
No, I didn't put it on the website. I want to give it out like personally in the class. So
Okay,
you saw the number?
No, I didn't.
It's in the group now. Oh, hold on. Sorry, I didn't send it to everybody. That was a reply. There we go. So you just reach out to that message for urgent stuff, for official stuff, like if you have a sick leave or anything like that, you have to send it via email and just send me a message so I know that it's there. All right, cool. All right, any other questions?
Sir, I was wondering if I could talk to you like after everyone leaves.
All right, cool. So you go after Gifford. All right, I think that's it for general questions. All right, so what I'm going to do is, oh, this going now. I'm going to stop the class and then do the meeting so that the meeting don't come into the class. All right, so.
Sir, I have a quick question.
Oh, go ahead.
I wasn't able to select our group. Is it possible for you to admit one?
Yeah, you need to be in our group for sure to get your group grade. So, Mikisha Lawrence. All right, I'm going to drop you in our group. All right, cool. Who else of them wasn't in our group again? It was somebody else. Oh, you had sent me a message, no?
2 persons, sir. Keithon and Shane McCoy.
Right. All right. All right, cool. All right. Any more questions? Good questions? Nope. All right, let me stop this thing now.